The purpose of example 9 is to introduce the concept of annual percentage yield, or APY. In this problem, it says assume that $100 is invested into an account earning a 6% annual rate of interest. Okay, so we are investing $100, and our rate of interest, our annual rate, is 6%. Okay. In part A, the problem asks us to determine the value of the account after 1 year if the account is earning simple interest. Well, you can kind of work through this problem in your head easily enough, but just to use the formulas, A is equal to 100 times 1 plus the interest rate times the number of years, which in this case is 1. So this is going to be 100 times 1.06 if I calculate everything inside the parentheses. And the answer, of course, turns out to be $106. Okay, so using simple interest over the course of 1 year at a rate of 6%, I'm going to earn $6. Okay, that's straightforward enough. In part B, it asks us to determine the value of the account after 1 year if interest is compounded annually. So A is going to be 100 times 1 plus I. Now, since I'm compounding interest annually, I is actually equal to 1.06. It's just my annual rate. Raised to the number of years, which is just going to be 1. So my answer here is 100 times 1.06. I actually get the same amount. Well, that's not terribly surprising because I'm only compounding interest once in this scenario. I'm using annual compounding, and I'm only looking over the course of 1 year. So I end that year exactly where I would have been if I had used simple interest. Now, these two problems, Part A and Part B, simple interest versus compound interest, these are going to start diverging as I go into the second year. The simple interest problem is still going to earn $6 a year in interest, but the compound interest scenario will earn a little bit more than $6 every year. And in fact, the amount of interest it earns will increase over time. But anyway, after 1 year, the balances will be the same. So now let's see what happens if we compound monthly. Okay, so if we use monthly compounding, my monthly interest rate is going to be 0.06 divided by 12. That's going to be 0.0005. Sorry, 0.005. So A is equal to 100 times 1.005. I'm looking at 1 year, so that's 12 months. And then if I go ahead and calculate this, I get $106.17. So I actually get a little bit more than $106. This goes back to example 2 in this section, where we discussed that the more frequently we compound, the more money we make, even though the difference is small. Okay, so in part D, it asks, basically, what rate of simple interest would we have had to have earned to end up with this amount of money at the end of the first year if we were using simple interest? And the answer is, well, we would have to have earned $6.17 in interest on a $100 investment. So it's not too hard to reason out that would amount to a 6.17% interest rate. So the idea is so let's say, looking at parts B and C, in both of these we're using compound interest. In one, we're compounding annually. In the other, we're compounding monthly. Whoops, I'm sorry, that should have been a 2 here. Okay, so in one, we're compounding annually, and in the other, we're compounding monthly. But let's say you invest your money at the beginning of the year, and then you don't really care what happens throughout the year, but then you come back at the end of the year to see how much money you have. In part B, you invested $100, You came back 1 year later and had a $106. So, for all intents and purposes, effectively, you earned 6% over the course of the year. Now in Part C, you invested $100 at the beginning of the year. Then at the end of the year, you came back and had $106.17. So, effectively, you earned a 6.17% rate on your investment, even though the annual rate was actually 6%. So that annual rate that we give, that R, is actually called a nominal annual rate. It's an interest rate in name only. If you want to know effectively what rate you're truly getting over the course of the year, you need to calculate what's called the annual percentage yield, or APY. And I'll show you a formula to do this in the next example, but essentially what we did in Part C was calculate the APY. We saw that the APY for monthly compounding here was not 6%, it was actually 6.17%. It was a little bit larger. And this also starts to explain why monthly compounding is a little bit better than annual compounding. You actually get a slightly larger interest rate. Okay, so now let's go on to example 10, and we'll see how to calculate APY in general.